Let's get started. So here's the solution. Yeah. So we mean he's just putting. This is Adam's little exercise actually. So he's just putting a bunch of corrupted words, and then after fitting the model, simply checking how they perform. And so the model is, of course, memorized everything, so it has perfect, nearly perfect accuracy. But when you feed it corrupted words, see how well it does. Yeah, so it does a good job of the 23 examples, but then WBC, it says is Y, right? Yeah, WKL it thinks is Y. So it's basically treating WTU as WXY and giving Z. So it's obviously performing horribly on even minor corruptions, right? So.
But what would be the correct answer? So it's really performing horribly? Or?
No, and the correct answer is it's just you have 23 data points. I mean, the point is just it's just a what do you call it? A teaser for what we're about to do now, right? Because these models, first of all, you really need lots of data, right? So you're just like doing some local optimization on some architecture.
One thing it seems to be is that if you have the W in the first position, then it really gives you back something close to the W, Y or Z. But if you have it in the last position, it really gives the next one as if it wasn't a W there, but the correct order. Like PQ and then W gives you S, which would be the one if you have an R instead.
Yeah.
So it seems to put more weight on the first than on the...
It's hard to know, right? Because you see what I mean? Because there's only 23.
And we all have 7 or 8 now.
Yeah, exactly. So we don't know, like this is, don't take it too, I won't take this too seriously, except that, if the slightest noise, it won't perform very well. So let's just continue with this. So what Adam has is this really nice example he makes from somewhere. It says here. Okay, so if I wouldn't do this because it'll take like 70 minutes or so. There is a notebook 61. So let me open it somewhere else. Here. It's still running. I started this at 9:40 or something. So what's happening in this notebook? Okay, so I'll come back to this in a sec. So let's go this here. So this is actually where the code is from, the one we were just running. And what it does is it tries to synthesize English language text from a single author corpus. So it essentially can read in data. So it's exactly this Harry Potter thing. We're doing that, except we fed it Nietzsche's text instead of Rowling's text. Okay. So here are the few differences between what we were just doing with this alphabet sequence to this more serious LSTM with a much larger data set. So the way the inputs are encoded, so here 1 hot vectors are used to encode the inputs. And then there's also a significant difference in the way the outputs are generated. So instead of taking just the most likely output class from the softmax layer that we did with this example, in the bigger one, we're going to sample it according to the probability distribution directly. Okay, and these things are coded. So if you look at the code, so this is This is what the code looks like. Let's actually directly go here and look at the code. So this is running right now. So Nietzsche's writings. Yeah, and this is the other problem, right? You generally want to run these things on graphical processing units and lots of computing power. So community edition, you're going to be quite crippled. Okay, so we import various layers, sequential, dense activation, LSTM layers, and various optimizations and so on. So here is the text. So we're grabbing it from S3 in Amazon, sort of a public grab. And then we're converting it to lowercase and finding out the length of the corpus. And we're converting, we're doing enumerations and converting characters into numbers. And then these are all parameters you can play with. We make the max length to be 40, step to be 3, and then so we're basically generating in strides of 3. We're basically generating sentences and next characters. And then we're vectorizing into type bools and using this X and Y as our input to build the model. So we have 128 nodes in LSTM, and the input shape is 40, and the length of the characters, right? So it's not 1 anymore.
I have a question.
Yeah.
So the X here, when you create the vector, so it's so going here line 49 and 50.
49, okay, or 43.
No, 47 and 48.
Okay.
So you're taking every word in a sentence, and for that word you're creating a vector, length of the alphabet.
All right, let's look at the code output, right? Because I just ran this. So let's just because I just be really shoot. I think we should just run this block. Let me just so this is what you want, right? Let's try to really understand this. Yeah. Okay. So let's go here. And drop it here. Okay, so this should just work. Did I grab? I think so. So my corpus length is, what is it, 600,901 characters, right? Am I right? It should be characters, the length of the text, length of a string, right? And then these sequences. So that's taking a while to do that. Okay, I'm really hammering super hard on my little community edition because that other job has been running for a long time. Is it done? Yeah.
Yeah.
So now let's see. What should we see?
Can you display X or Y? No X.
X. Okay, so this is just a whole bunch of falses and trues, right? It's one hot encoded something, right? So so we have numpty of zeros, and then it has right. So length of sentences, max length. Oops, max length. That's it. So this is the shape, right? 200,287 by 40 by 59. Okay, so I'm making this massive thingamabob of, what is it? It's a tensor, right? Well, whatever, it's a three-dimensional array. And I'm making it of type bool just to save footprint, right? And then I'm loading X. So let's get X of yeah, I mean, so let's say X of right. So this is basically encoding the ith sentence, the teeth character, and the index of the character.
Yes. So what I'm wondering is, are you encoding words as basically the alphabet, and which characters from the alphabet are occurring in that word?
I think we are just. I think everything is at the level of characters, right? There's no.
But the word, is it encoded as a vector of which characters occur in the word?
No, there is no notion of a word here, right? It's like a really stupid model with like.
Ah, okay, I see. Right.
I mean, correct me if I'm wrong, because I'm just looking at it in detail right now. So I think so, right? Because we just basically take a one huge string,
but
and
there's a notion of sentence.
Yeah.
Sentences.
So I think these are the ones, because let's see, the sentences are the ones that are going into the initial thing, right?
The sentence is a 40-character long.
Yes, that's correct.
So just
exactly.
The text into 40-character things and calling them sentences.
Okay,
that's right. So those are in like your 23 in the previous, there are 23 instances of triplets followed by a single character.
Okay.
For the 26, it's like that here.
Okay. And then for every index in that sentence, you see which character it is.
Yeah, well, yeah, so you have to map the character to some enumerated, because we need everything to be numeric.
Okay. I think I get it, but it's a weird mapping or encoding. So
yeah, it's the most naive one, right?
Non-obvious. Non-obvious code encoding for me.
Yeah, true. Yeah, I mean it's almost the same, except it's one hot encoded, like you mentioned, right? It's one hot encoded. But the only difference now is we take the full corpus. We decided, didn't we specify? Yeah, we specify how long it is here, and then anyway. So did I kill this, or is it still running? Oh, it's still running. So let's just look at the other thing that's different is, okay, once we set up this simple LSTM, the other thing that's different is the sample. So the way remember Adam says the output is actually not the most, what do you call it, the most probable output from the softmax, but it's actually a sample from that entire distribution. So it's a random prediction. So this is what's going on here in this function. So we take the preds, and then we have this extra parameter called temperature. And all we do is just throw in this temperature term here. So we take np.log of pred, so that'll be a vector of the log of the output from softmax, and then we divide that by temperature. So when the temperature is basically really large, you're going to get a uniform distribution. The temperature is really small, it's going to get highly concentrated, right? The most probable value will have all the mass if the temperature is small, and if it's really large, then it should have a uniform distribution. Okay, so you can just copy paste this and play with it, but it's like an extra tuning parameter to decide how you want to heat up the temperature, discrete temperature, the probability vector that comes out. Okay. Yeah, so this normalizes it after heating it up, and remember, think about this way: if temperature is 1, then preds is np log of preds, and x preds is np.x of np log of preds. So nothing has changed. So if temperature is 1, we're in the whatever vector we put in, probability vector we put in, we get it back. Okay, and then once he has this thing renormalized, then he sort of pumps it into the random multinomial. So we're now drawing from this multinomial distribution that's been heated up or cooled down. So that's the only other real change. So here we're simply going through many iterations and training the model. In each iteration, we're training the model, see? And then, so this is training each time on a batch size of 128. And then so diversity is basically the temperature parameter. I don't know why it's called diversity again, but yeah, so when diversity is 1.2, there's more diversity, so the output will be more diffuse from the actual predicted probability vector. And if it's 0.2, then it'll put a lot more emphasis on the high probability events, basically. Okay, so yeah, so for each iteration, the prediction is coming from 5 or 4 different temperature terms. Okay, so yeah, it's been running for a while. You can see, this is going to be the problem with your idea, Gustav. So if you do LSTMs on the community edition, then well, the data shouldn't be too big. But it's not too bad, 1.5 hours. So what you should be seeing is outputs coming periodically. So let's just look here, because this is copy pasted here a little bit. So some snapshots. So iteration 19, you have some of the generated. So with a particular seed, this is what's being generated. Apart from the value of such assertions, the present of the super CLE and the soul, I don't know. It's not that great, but it sounds kind of philosophical. And I guess in iteration 32, you have yeah, seems a little bit better. body as part of this external world. And this is actually Adam. He sort of says something strange happens in iteration 38, you know. This is completely crazy. Look at this. So he's wondering, you know, his question, you know, what might have happened here? Because it was pretty sensible, right? Suddenly it's like off the, like, worse than a monkey. I mean, I don't know. I mean, it could be like some strange, you know, you're doing so much hacks, right? It could be anything, right? It's something to do with the optimization algorithm on somewhere else, stuck somewhere else, maybe.
This generates.
So, yeah. I mean, so the moral is, you know, you have to be really careful in all of this. And this is, again, the simplest possible model of LSTM, just character feeding, right? So I want to point out that there's a lot of hype around AI, and you need to really mind it. And this is this Harry Potter thing. So if you actually look at the Guardian report on it, you know, Guardian is supposed to be more educated readership. So they are like, this is the, he began to eat Hermione's family. What tries to write Harry Potter book fails in magic ways, right? So yeah, so you know, it's a more, you know, interesting take on it. But if you see the same from another popular press that a different kind of community reads, like the Business Insider Nordic. This is a new chapter in Harry Potter's story. There's a new chapter that's written by artificial intelligence. It's, you know, and yeah, slightly critical. Let's see, look at this. The writing is mostly weird and borderline comical, but the machine managed to partly reproduce original writer J.K. Rowling's writing style. I don't know. Anyway, I just want to tell you that, yeah, just be careful what you read about what's going on. And I mean, the main thing is, you know, you will always have like managers who are necessary in a sort of a proper industrial data science process. You know, you can't survive without them. But a lot of them tend to get psyched, in my opinion, about the latest hypes. Maybe that's how they keep themselves going. And AI is a really huge hyped up thing. Of course, it's very useful. Of course, we can have autonomous driving vehicles. But whether the machine is intelligent, I don't know. This is philosophical. Right? So yeah, I don't know. Yeah, so I think you need to be, you know, be a bit practical, right? Because you guys know enough maths and you know the cold reality of additions and multiplications under the hood, right? So it's not really just magic. Again, I didn't have enough time to get into this. This is supposed to be a whole, you know, 2 hours on this. Ethics, you really are grown-ups. You can figure this out on your own. A lot of it is just common sense. And the best way is to, I already recommended this in a hurry once before. This is a really great book. So Weapons of Math Destruction. It's in fact, what is it? It's been longlisted for the National Book Award. That's, you know, as popular as math gets, right? But she's quite cool. I think her original stuff is mathbabe.org. It's still there, right? So she has an interesting history. So yeah, she was a Wall Street quant. Sort of understands a lot of the stuff. Kathy O'Neill. It's worth reading it. The other one that I like quite a lot. I read it while I was working for this startup, building software for intelligence organizations. This one, because I mean, at one point I was actually kind of starting to freak out. Like, it's like, oh my God, what's going on? And so, yeah, there's a lot going on, and I think it's good for you to know what's sort of going on, especially in mining information, behavior profiling, because a lot of the data science jobs are actually on that, layer, and there's a lot of data out there. You need to know both the security angle, the privacy angle, and the legal angle, which is changing quite a lot. So those are very good books. And there's some pointers I put here on legal consequences for doing data science, and you cannot say, oh, they made me do it, I was following orders from my boss to get a bonus. It's not going to cut it, right? There's instances of people being in jail, and this is like including the VW, Volkswagen scandal. This is software engineers, but basically data science. So anyway, just take a look at this. US has its own, I don't know, keeps changing a lot. India, for example, it's illegal to predict elections. And even if you just kind of blogged about it, it's illegal. I don't know what Indians will do, but that's a really recent law. Anyway.
It's illegal to predict the outcome.
No, let's read this. I mean, I sort of just looked at the forecast of poll results illegal, election commission, Okay, just I'm sure things are going to change a lot, right? Because I put ... because when Amazon starts operating from Swedish soil, like, it's a huge game changer for a lot of activity. What's considered legal now will be illegal and punishable by Swedish law, even if you're operating from wherever in the world. Okay, if you're using the data centers on Swedish soil, commercial or not, and manipulating the behavior of Swedish citizens or EU citizens, then the current EU laws, up to my understanding, allow Swedish laws sovereignty within the EU laws to actually hold operators that are manipulating human behavior for their own goals accountable. Right? And these goals are fine as long as they mess with law. So if you're doing whatever, instigating genocide is an extreme example, but there's a lot more. And GDPR is, it's quite a lot you need to be aware of. Okay, so in the next, I think these are just those solutions. I wanted to put a bit more on generative and adversarial networks, but you'll figure all of this out. You think you guys have enough foundations now to learn on your own. So I kind of have a plan to do something, the last 7 minutes, showing you guys how I generate the notes. Like, we'll just pretend to create a new notebook for, say, in the future. But if there are any sort of questions, we can chat for 4 or 5 minutes now. General questions.
When you will be available for meetings, in case you need one?
For projects, so we may have to Google Hangout or Skype or something, because I'm technically going to be on leave from Monday because I'm moving. So I have holidays this year, and my wife is going to make me take them, which is good. I have to help her move, right? She's small, short. So because our new flat is on the 4th floor, and there's no elevator, the old flat you could buy. So anyway, but Friday I can check back at emails more carefully, and we can, I guess, yeah, let's look at the calendar, because I don't know. So, but you guys are kind of set, right? The default plan.
I don't say we need, but in case we need.
So what I would recommend, remember you guys are supposed to, everyone except Mariana and Lee, and you guys after you do your anonymization.
Oh, yeah. It's done. Right? Yeah.
Oh, it's done already? Okay, wow. Okay, so, so like some baby, not necessarily the full data set, but a interesting big enough data set, maybe you put it somewhere that you can doubly get. And then this Databricks notebook. Remember, if you make a pull request, like there are instructions somewhere, right? Then I can actually open it and see it, and then we can start. I can start modifying it, making suggestions, and pushing back. So there will be some. I don't want to email notebooks back and forth. It'll be a pain, right? That's why we sort of have this nicely set up. Also, it's a public record of you actually contributing something, and so we can all do it through just the DBC files because they're just jar files anyway, and then we can, so I can open it, edit it, save it back, and then you can pull it. It'll come back to you. You can push.
By the way, if you don't export to what's called SDB, what's the format?
No, it's DBC.
You can export to source file instead.
Yeah, you can.
And then you can get the changelog on GitHub and just see what people.
Yeah, you can do that. That's what I do by default. I just did the DBC because it'll just be, it'll be
The difference is that for DBC you get the output, right? That's preserved.
Yeah.
But otherwise, you can then also see with source file you can see changes and you have a trace of what's going on.
Yeah, in fact you can make a PR to both, right? So you can export the DBC and also the .scala or whatever, .python, whatever. I think everyone pretty much is .scala, right? So yeah, you can do both. That'll be good. And name it in a reasonably sensible way, like maybe just the last names of the people in the group, alphabetized, right? So yeah. So that way I have and then so change the last name to uppercase, camel case. Yeah, and then I can be there, right? I can look at what you're doing in the middle of the night, early in the morning, anytime, right? So then we don't have this physical meeting problem. And then if I really need to talk to you, then I can hang out. And maybe just write an email saying what you've done, what you think you want me to pay attention to, or whatever, then that would help. Okay, so let's just do 5 minutes of what I would have liked to do, say if we had another week, for example, right? Okay. Yeah, and forget about the other things with deep learning. But one thing I really wanted to look at is, so I remember from Spark Summit.
Just
yeah.
a quick question.
Yeah.
Do we have access to a what do you call it, projector during our presentations?
Do you have access to the project or?
No, like
the projector.
Yeah, projector.
Oh, how do you?
Are we supposed to have a presentation, a slide?
No. You'll do exactly the same thing.
Okay, so just show.
Yeah, it'll be all just notebook based and.
Okay. Yeah.
Yeah, I don't really want the whole PowerPoint show on top of this because you can put MD and it'll all be rubbish in 2 months, man. All of this will be sold. It just doesn't matter. You have to pay people to look at this, right? You've seen the most famous blogs in deep learning was by 17-year-olds and stuff now. So just read whatever is relevant, right? So you can just link in those images. That's what I do. I don't even have a copy of the image anymore. I just link in from some blog that's really sensible. And if that image doesn't exist in the future, then I should just change the blog or what I'm linking to, right? Because otherwise, if you just download it, you will just get antiquated, If, you know what I mean? If you make your own copy of an image, giving them credit, then anyway, this is a different problem. But in general, right, this course is training you to learn on your own, because that's the whole point. You don't need to be an expert researcher in any of these areas to be very useful to local industry, right, the data industry. Okay, so I'll tell you what I wanted to do. Yeah, Apache Spark Summit EU 2017. I think this is the one that I attended. It's like pretty serious. Dublin, yay! It was awesome. Yes, Mate. It's the one yeah, let's just do this. There's so many of them, but what I expect you guys to be able to do, for example.
Thanks, Andy, and welcome everyone to Spark Summit Europe. Really excited to have you. So we have a really exciting and packed program for you in the next 2 days. This is our largest European Spark Summit, and we have 102 different talks, 1,200 attendees, and 11 different tracks.
All right.
Software engineer on the ML team at Database to give you a demo of deep learning Python.
So, starting now, right? 21 minutes.
Thanks, okay. So, I have a confession to make.
Okay, she's going a bit slow, but basically she starts, doing transfer learning. Okay. To sell shoes. So she takes
finding a pair of shoes I like.
Google's ImageNet that anyone can download and use that to do transfer learning to get features.
It's really exciting for me.
And then builds a shoe recommender from the shoe images. It's really awesome.
Unfortunately, it looks like this. There are
and then she gives you actually a link to a Databricks notebook with all the code.
On specialized hardware, it can take days, if not weeks. And even if you have those resources, it takes a lot of manually intensive parameter tweaking to create a great model for your task.
Yeah, this is the other problem, Gustav. Like, if you, in your particular project, it will be difficult. But in general, if you had an image-based project, then you can always transfer learn from some fancy model from Google or Baidu or whatever. These guys give it to you, and then you can just use that as a starting point, right? And often that was a big selling point for these
combined means it can take months
talks.
To get a good model.
You don't need this many resources to actually do it.
Deep learning models are complex, it means it requires a lot of often labeled data.
So let me quickly. So this is kind of what I do basically. Like I spend usually around 3 hours to get together content for say half an hour, and that should be roughly. Right, and then I usually read some stuff like a hard copy book if I don't understand some things. But that's kind of what's expected of a data scientist in the industry, right? You have to. You can do these things.
Familiar with it, nearest neighbor works by assuming that your data points in the data.
Yeah, so that's what she does is basically feature learns and then projects these things into a Euclidean space. Then she does a faster version of k nearest neighbor, which we didn't try. It's one of the things in the unsupervised learner classification section, because this version of nearest neighbor algorithm uses some kind of spatial indexing to speed things up. Anyway.
Space, that's that thing.
So yeah, if you're bored, and you do this, and make get this notebook and. And you can make a pull request, and we can. I have no idea where I'm going to be soon, so maybe we can pull and push each other. All right, guys, it was really fun having you. So see you Jan 5th for the project presentations. Otherwise, have a good life.
You too.
Yeah, thanks.
So we don't have exact time?
The 9 to 12, right? Yeah, I'll tell you the order in which you guys will go once we end everything. Yeah, well, that's my default plan, but I haven't reserved it yet, so I'll let you know. Okay.